How's it going, everyone? Welcome back to another episode of the Devlog. This should be episode 8. Last episode, we left off with some question marks inside of our TreeConstructionDispatcher. So in between episodes, I went ahead and did some research and figured out what those if statements should be. And this episode, we're going to go through, I'm going to explain everything, draw out some diagrams, and even tell you the direction that we're going to be moving forward in. With that being said, let's go ahead and hop in and get some work done. Last episode, we left 3 of these checks inside of the dispatcher or the TreeConstructionDispatcher because I wasn't really sure what they were, and I just wanted to get some more stuff done because I felt like we hadn't done very much work actually inside of the episode. So this episode, I want to go through and kind of figure out all of these, which, spoiler, I've already actually figured all of these out. I also got a new toy, so I'm going to go ahead and play with it. We're going to draw some stuff out, and I'm going to show you guys exactly how everything works. And once I kind of describe and tell you guys how all of these actually work, I'm going to go ahead and start coding these one by one, maybe even do some testing and things like that. Let's hop over to OneNote, where I'm actually going to explain to you guys what each one of these checks actually means and what each of these actual HTML elements actually are. Our first goal here is to figure out if our adjusting node is a MathML annotation XML element and the token tag is a start tag with the name of SVG. So the first big issue here is, what does it actually mean to be a MathML annotation.xml element? First, we needed to figure out what the heck MathML actually stood for. So what the heck is MathML? From what I found, MathML is some sort of like a library or a markup language that actually allows you to go ahead and create cool mathematical equations and things like that on the web. So what does this actually entail? So if you actually want to use the MathML library or the MathML markup language, you have to nest everything inside of a math tag. So what does that actually mean for us? So that actually means that our HTML is going to look something like this. We have a regular HTML page, and we have whatever we have inside of it. Then we'll have a math tag with whatever inside of there. So that means to be a MathML annotation-xml, it's going to look something like this. It's going to look something like this, where we have our same thing here, but inside of the math tags is going to have an annotation-xml. And the other thing to keep in mind is that it is possible to have this annotation.xml outside of the math tag. So that's why we specifically had to look for it nested inside the math. So in our case, the one on the left right here would be not correct. It wouldn't be a MathML because it's not nested inside of the math tag. But the one on the right here would in fact be a MathML because it is surrounded by the math tag. So that is the first thing that we need to actually look for. How would we actually go about doing this in code? Well, it's actually rather simple. All we have to do is 1, check to see if the adjusted node is annotation-xml. And if that's the case, we can move on to the next step. And 2, then we want to go ahead and loop through the stack of open elements and check to see if there's a open math tag, because if there is an open math tag, that means that the annotation.xml is actually a child of that math tag, which actually makes it a MathML annotation.xml. So it's actually going to be pretty simple, a lot simpler than I actually thought it was going to be. So I'm going to go ahead and hop into the code and figure out how to do this. And then I'll get back to you guys with the implementation and show you all how it worked. Start out our mission here to get all of the tree constructor done. I went ahead and cleared out the entire class of all the other stuff that we wrote last time. And I went ahead and made a dispatcher utils class. And here I have a whole bunch of static methods I'm just going to be using inside of the dispatcher. And at this point, I just got us back to the point where we were last time. So here, the first thing that we need to check is if the stack of open elements is empty. So that is nothing special. We just go ahead and get that stack of open elements from our state object and check if it's empty. Then we check to see if the adjusting current node is in the HTML namespace. So again, I just took the method from the tree dispatcher and I went ahead and put it in here. Nothing special here. I could probably make this a little bit better, but it is what it is. And then finally, I went ahead and did the MathML integration. These ones are really long, but you know, it is what it is. So this one is MathML integration point is a start tag whose name is not mglyph or malign mark. Again, we just have a first method here, check to see if it's an ML integration point. Again, this is just if the names equal one of these. And then we also made a method to see if it's a start tag and to see if it's the name is whatever it is. So the actual method just checks to see if it's an integration point, if it's a start tag, and if the name is not one of those two. And then similarly, we also did the MathML text integration point and character token. So again, this is just going to check to see if it's an integration point and if it's a character token. So now at this point, we can actually do the new stuff. I'm going to get to coding and I'll give you guys some updates as we get going here. After figuring out what it actually meant to be a MathML token or MathML annotation XML, it's not actually that hard to get it figured out. We went ahead and created a new static Boolean method in here That way we can check to see if it's a MathML annotation XML element. And all we actually do is go ahead and get the element or the current node, as well as get the name of it. First, we want to make sure that it is in fact an annotation.xml. Of course, if it's not even an annotation XML, it can't be true. And then we do a little bit of a trick with an iterator where we can just loop through all of the elements. Now remember, we don't actually want to pop any of these off because we need them in there for now. So that is why I'm using an iterator here. And all we're going to do is go ahead and loop through each of the elements. If we find one that equals math, we'll go ahead and break right out of there. I don't want to do the extra work and then return that. Otherwise, the is math element will be false whenever we go all the way through the loop if we didn't find it. Up here, I cheated a little bit and I went ahead and just reused some of the methods that we already had. So of course, we check to see if it's an annotation XML, then we check to see if it's a star tag, and then we see if the tag name is SVG. So that one is good to go. Now we just have two more that we didn't know for sure. So let's go ahead and hop back into OneNote so I can explain to you what these are, and I'll get these methods going as well. So the next big one that we couldn't figure out was actually if an adjusting current node is an HTML integration point, and then there's some other things in there as well. So there's a few different things that actually make an HTML integration point. The first one being whether or not it is a MathML annotation XML. Obviously, last time I went ahead and figured out what that actually meant, but it also is going to have a couple of special properties. And the first one is that the MathML annotation XML should actually have an attribute called encoding. And also the encoding attribute has to have the value of text/HTML or application/XHTML plus XML. So this one should be pretty simple because we already know how to figure out if it's a MathML annotation XML. So we can just kind of go ahead and check that one off the list. The second one is that it's an SVG foreign object element. So again, I went back and did some research. SVG is scalable vector graphic, and it essentially allows us to kind of input some graphics into our HTML or some images that are resizable into our HTML. So again, it's going to be wrapped inside of an SVG tag, just like the MathML is going to be wrapped inside of a math tag. So this is going to make it pretty easy for us to figure out. So again, all we have to do for this one is first check to see if the element is a foreign object, which should be pretty simple. Then of course, we just need to check the stack of open elements for SVG, and that will actually make sure that it is a foreign object element of the SVG type. The next check is for an SVG description. Again, same thing. We're going to first check to see if it is a description element. Then once again, all we have to do is check the stack of open elements for the SVG tag, and then we'll know for a fact that it's nested inside of the description. It doesn't matter if it's multi-nested or anything, as long as it's inside or a child, some sort of descendant of the SVG tag, it should be fine. And the final check is for an SVG title element. This is going to be the same exact process as the other two. We'll check to make sure that the element is in fact title. Then of course, we'll check the stack of open elements for the SVG tag, which will then go ahead and tell us that this is in fact an SVG title. With that being said, we should be able to finish up the TreeConstructionDispatcher now. So let's go ahead and hop in and do that. And then maybe we'll get into some testing near the end of the episode. I'm not sure how long it's exactly going to take, but fingers crossed we can still get this video out this week. So I finally got the HTML integration points finished. So I went ahead and added these two here, but we can go ahead and take a little bit of a deeper look. There's a few things that make an HTML integration point. The first is that it is a MathML that either has text HTML or application HTML plus XML. So all we did here is we first checked to see if it was a math annotation XML element, which is what makes it a MathML element. Then we went ahead and got the attribute list. First checked to see if it contained the encoding attribute and if the encoding attribute actually equaled that. The other thing was whether or not it was an SVG, either a foreign object of SVG type, a description element of SVG type, or a title element of SVG type. So all we did here is went ahead and checked to see if the name of the element was one of those three. Then we did something similar to our MathML. We just looped through all of the elements inside of our stack of open elements and see if there is an SVG element. If it's nested inside of SVG, then that means it's SVG foreign object, SVG description, or SVG title. If so, we'll return it. Otherwise, we'll return false. And then of course, after that, we had to do a couple other checks. So the first one was to see if it was a HTML integration integration point and start tag, or if it was an HTML integration point and character tag. So now we went ahead and put those in here, and now this should be all good to go to check whether or not we should do normal insertion mode. So now at this point, I had this token parser. I actually want to refactor this a little bit and do it something similar to our tokenizer, where we have a tokenizer state manager. So I'm going to create a tree construction state manager, or an insertion mode state manager, I suppose, and kind of run that in here. And then I think that I might still have a little bit of work to do on the initial state. I might do that as well. We'll see. But I do want to get this episode out because things are about to get really busy and I don't want a long pause in between episodes. So I'm going to go ahead and wrap up this work and then wrap up the episode here in a little bit. I finally got a whole picture in my mind of what this whole process is going to look like. So of course, like we've already mentioned, we're going to have an HTTP request probably from outside of our service to get some information from a page. We'll go ahead and send a GET request for that page, and that will return the string of the entire document back to us. At some point, I may change this. I'm not 100% sure yet. We're just going to have to wait and see. From here, obviously, we go ahead and make this so that it's safe to be parsed, and we send it over to the tokenizer, which will go ahead and add tokens to the emitted token queue as necessary. For now, we're just going to bypass the multi-threaded nature of this, and we're going to go ahead and get the entire emitted token queue finished out first, but then we'll go back and refactor later on. But in the diagram here, I went ahead and made it so that it is circular so you can see that. So obviously, after we get done with the emitted token queue, we're going to pass that along over to the tree constructor, which is going to actually take all of those tokens and figure out what the HTML document is supposed to look like. From here, we're just going to loop through the emitted token queue, removing token by token as we go, and then going and passing the token over to the TreeConstructionDispatcher to figure out if we need to do a regular old insertion mode or to do something else. From here, we'll decide which insertion mode through the insertion mode state manager. It'll call the correct insertion mode and then actually do some logic, pass the state all the way back, and do that process over and over again until the emitted token queue is completely finished. Once that emitted token queue is completely empty, we should have some type of HTML element that we can actually send back to the client, aka another service, to actually get information out of there. Now, there are a few observations that I've found. Right now, we're utilizing Spring, and a lot of our things are components, and by default, components in Spring are going to be singleton. This is obviously going to cause an issue if we have multiple requests coming in at once and we're trying to use the same exact state object or same exact emitted token queue or whatnot. So either we need to go back through and make these so they're not singletons, or we need to go ahead and make them so they're not components. I'll go through and figure out which way the other that I want to go, but this is going to be some things that I go back through and figure out later. There's also some things with the tokenizer that I don't like, so I'm probably going to go back through off camera and figure all of that out because I don't want to bore you guys some more working on that stuff, which we've already fixed up. But after all the editing and all the other work I've done, I found out that it's actually time to go ahead and wrap up this episode. We actually got a lot done because there's a lot of research going on behind the scenes, and now we've actually set ourselves up for a good bit of work moving forward. Here off camera, I'm going to do a little bit of more research and try to figure out all these little small refactoring that we need to do. Hopefully I don't have to refactor too much, but I hope you all enjoyed. As always, if you guys liked it, please leave a thumbs up. If you didn't like it, leave a thumbs down. Either way, it helps out with the YouTube algorithm. Please leave a comment with what you feel like and how you like in the series so far. And finally, subscribe if you're new. Hit the bell icon so you don't miss any videos like this. As always, this has been Ethan on Koder. I appreciate you all. Peace out. Have a great day, and I'll see you guys in the next episode.